Welcome to the third day of the CUAHSI virtual biennial. We hope to see you soon in person, but today we're continuing with our virtual panels. The first two have been great. I hope you've been able to see them. Today we're having awardees of CUAHSI grants present. This is one of the most exciting things that I think we get to do at CUAHSI. We give about $80,000 in grants to students and early career individuals every year, and we get some really cool outcomes and things that help people's careers as well. Today we'll have 7 talks from the different grants and training that we do. And we'll just go in the order that people have signed up here, and I'll be running the slides. As a reminder, the session is being recorded. And if you have questions, pose them in the question Q&A panel and not in the chat panel. So we will start with Morgan DiCarlo, who was the winner of the first Voices of the Future Award. Morgan, introduce yourself and please carry forward.
Hello, everyone. My name is Morgan DiCarlo, and I attend North Carolina State University. And again, yes, I was one of the inaugural recipients of the Voices of the Future Award. Next slide, please. I'm a PhD student in civil engineering, and my research relates to water systems. And particularly, I'm interested in human behaviors during water-related hazards, including one research project that analyzed how people form a help network on social media during hurricanes, and my current project, which involves reviewing smart meter data to understand whether a population conserved water when they were asked to by their utility. Next slide, please. And one more click. My graduate research inspired me to apply for the Voices of the Future Award because I focus on hazards and water resources. It's important for engineers and scientists to view water as a system, one that is strained by dual threats of climate change, and next click, please. Aging infrastructure. There is a water main break every 2 minutes in the United States, according to the 2021 American Society of Civil Engineers report card. And according to this week's drought monitor, 76.7 million people in the US are affected by drought in real time. And one of the framing points for my essay for this award was, we need innovative and paradigm shifting solutions to address these dual challenges. Next slide, please. In preparing for my essay, I read the recent publication, 23 Unsolved Problems in Hydrology. And my paper takes a focus and speaks to one question in particular: how can we extract information from available data on human and water systems in order to inform socio-hydrological models? Next slide, please. And one more click. Yeah. As discussed throughout this conference, it's important to integrate perception and hydrological models, and water should be managed as a socio-hydrological system. So in addition to climate change and aging infrastructure, as we can see in this top graph, water withdrawal is outpacing population growth. And next click, please. There are alarming global trends linking economic improvement to increased water use. And as you can see, population size and economic conditions are just some of the ways that social factors affect our water supply and people's water use behaviors. Next slide. So one of the key talking points in my essay was how historically the largest spending efforts in water management have been supply side approaches, like structural interventions like dams that help us develop new water sources when there is rising demand in a certain city or area. However, it's no longer sustainable, and soon will not even be possible to simply source more water and divert it towards urban centers. So the future vision I described involves really scaling up and making much more robust demand side management tactics with behavior-centric approaches like big time investment in smart metering, conservation incentives, and pricing changes. Next click, please, and next slide, please. Thank you. Demand side management is being employed today, but it could be financed and implemented at a much larger scale, which is sort of the future that I described and envisioned in my essay. if we switched our management focus from supplying water to conserving it. I believe we have a unique opportunity to capitalize on the boom of information communication technologies that everyone is integrating as we widespread adopt the internet into our lives, into our homes, and into our devices. And if we can better integrate the social data being generated by smart technologies into our water management approaches, we can get an edge. Smart meters can help utilities identify losses due to leaks, alert customers when they approach tier limits, enforce time of use restrictions on outdoor water features like sprinklers, and validate how effective conservation campaigns really are. Next slide. It's time to capitalize on information communication technologies and to expand and improve demand-side water management approaches. So I focused on several examples that integrate human and water already. And these included social incentives, and I highlighted a few programs that are piloted that I think could be at a wider scale in the future. So there's a program in California called Water Smart that allows consumers to see how their water use compares to neighborhood averages and creates this kind of peer pressure to reduce water use. And also Internet of Things-based approaches. There's new devices that are smart faucet or smart shower devices. And one that I did a brief lit review on called Amphio had 22% use reduction in pilot. And what it actually does is let you know how much water you're using in gallons while you're showering. And it had a real incentive for people to, finish up and use less water. And also there's a practice of gamification. One utility in Switzerland started this program called Smart H2O, and it's a visualization software for people's water use that also gives them badges and games and incentives when they reduce their water use. Next slide, please. So the thesis of my essay was that it's time to capitalize on information communication technologies to expand and improve demand-side water management approaches. And working on this essay competition, it inspired my new research direction with my PhD work. I have a project analyzing smart meter data from utilities to understand how significant events are affecting people's water use. So these are just some brief summary figures from the data sets that I have, but in the top figure on the right is just an example of what I'm observing during a water main break event at a North Carolina utility. So there was a significant water main break and they communicated to their customers, please conserve water use. And then we can see the evidence in their smart meter data. There are shaved peaks in water use after the utility communicated to their customer base about the pipe break, that's in red, as compared to the usual behavior in black. I'm also observing how use changed across a set of customer meters before in blue and after in orange stay-at-home orders due to COVID-19. The daily pattern of water consumption completely changes with no low peak as people are leaving their home for work and school. So I think it's incredibly interesting to study the interplay of people's decision-making and water resources. And hopefully the future of water will involve improved management approaches that empower people to be less passive about their water consumption and alert about water conservation. Thank you. I think I'm at my time, but please connect with me on LinkedIn and I look forward to your questions.
Thank you, Morgan. Next, Laura.
Thank you, Jerad. Can you hear me okay?
Yes.
Hello, everyone. I'm thrilled to be here with you. My name is Laura Rosales Lagarde, and I'm a assistant professor of the Environmental Resource Science program at Nevada State College. This is just south from Las Vegas in Henderson, Nevada. And I'm going to be talking to you about the research we did and the gains we had through the Instrumentation Discovery Travel Grant we received in 2019. This is titled Open Source Data Logging, Hydroclimate Research and Teaching. And this was done in collaboration with Patricia Beddoes and Edward Mayon from Northwestern University and the CUAHSI project. Next slide, please. So what I learned through this travel grant, thanks to this grant, so I learned to build data loggers, which you can see me in the middle, building data loggers in Evanston, Illinois. That's what the grant helped to pay for. So I learned about electronics, about sensors, about programming, troubleshooting, calibration, deployment, and data analysis. And I was able to build the data logger that you see in the lower left image over there. And with Patricia, I also learned about doing some data analysis, as you can see on the right image. Next slide, please. Also, I learned how to deploy an open source data logger to measure changes in water temperature at depth at Lake Mead. After I traveled to Evanston, then Patricia and Ed came to Las Vegas, and with the help of my students that you see over in the pictures below, we deployed 2 strings of thermometers at Lake Mead to investigate how temperature change at depth. And why this is important, well, you have heard, especially recently, that Lake Mead has reached the historical lows, and knowing the water temperature will help us to better do a water balance and understand evaporation. So on the graph on the top, you can see the y-axis is 0. At the top is the surface, and at the bottom is 6 meters depth. And we measure temperature over the 4 days. And on the left, the red numbers are like the red is 31 degrees Celsius, and the lowest green is 26 degrees Celsius. You see the diurnal variations of temperature. It's pretty hot still in September, but then by the 3rd day, we had a cold front came in, and temperature completely cooled down, and it homogenized thermally over there. If you can go to the next slide, please. So I also learned how to teach how to build data loggers. So I learned that implied learning about the pedagogy on how to run a class using project-based, and emphasizing the students documenting their work and the growth mindset. There's lots of opportunity for mistakes, and it's okay because it's part of the learning. I learned how to order the supplies and the parts needed, because it was like a lot of components were new, and you can see the images over there, also assembling the student sets for the class, and again troubleshooting when things don't work. Next slide, please. So I also learned from my students about how temperature changes through different processes. So you can see pictures of my students. They investigated about the composition, mulch, and the temperature at mulch and non-mulch areas, about vegetated and not vegetated areas, how temperature change when you water your plants, or how temperature changes at urban and rural settings, and how temperature changes at depth in the soil. Next slide, please. So these are some quotes of what my students learned. So I'll just take a pause and let you read some of them. So these, I'll go ahead and move to the next slide, please. So I think my students learned what I learned, that is just this type of learning how to build data loggers helps you to be better users of commercial data loggers, and it builds your confidence on using them. So some of the professional benefits of this travel grant for me is I have been able to continue measuring changes in Lake Mead water temperature at depth, and I hope to continue doing this research related with the response to weather, and build my confidence as a teacher, as a researcher. And as I was mentioning, because this class was successful, now it's officially part of our program. And we were able to continue the collaboration between my college and Northwestern University and the Kepler project. And I also learned about CUAHSI since I didn't get the chance to do so. So you see on the right an example of my own deployment of the data loggers, and I hope to continue doing that this semester with my hydrology students. And that's it.
Thank you, Laura. Very good. Arash.
Hello, everybody. My name is Arash Jerad, and I'm a PhD student at Boise State University. I received the HydroInformatics Innovation Fellowship from CUAHSI last year during the summer. And I used the award to develop an app that can help map water bodies every 16 days from 1984 until present. I disseminated my work in HydroShare, in GitHub, in Google Earth Engine, and it's an open source code. So if anyone wants to change it to their benefit or use the code in any way for their own project, it's available and it's there. And I really want to mention that this award really helped me, particularly during the summer, to dive into this problem, because this was not like a major problem in my thesis, but it really helped me dive into it, explore it, and have some great ideas at the end and results. Now, next slide. So I'm going to talk about some of the research that I did and some of the challenges I faced during my research. As you can see in these images, there are certain types of background features that can be problematic when delineating or mapping water bodies. One of them being cities. And there are like different features in the cities, like very bright rooftops that have high reflection and reflection properties similar to that of water bodies. And there are like asphalts that are low reflection, and they cause misclassification errors when we try to map water bodies. And surprisingly, at the images at the bottom, you can see dark vegetations. Those vegetations, the changes in near infrared and visual parts of the electromagnetic spectrum, they have the same proportion to that of water bodies. So they can also be misclassified as water bodies, and that's something that's rarely discussed in literature. And you can find those types of vegetations, dark vegetations, in some parts of the world that creates misclassification errors. Now, next slide, please. Here you can see three different types of bodies. The subfigure A, the one to the far left, shows a very cold water body where there is like ice inside of it. Those ice and cold water bodies can be misclassified as non-water and as the background noise when we delineate water bodies. And that's something we helped improve when delineating water bodies. In the middle, you can see muddy waters. They also can be classified as non-water when we try to delineate them. And that's something we have to account for. And to the far right, subfigure C, you can see that some of the shadows induced by mountains, they have also similar spectral properties to that of water, and they can be misclassified as well. Next slide. So the idea was to come up with an index that can capture all of this, and in the literature there are actually different ways to do this. One of them being the indices. So they are easy to use. They're not computationally expensive, and they're not demanding in terms of computational performance. But there are machine learning approaches as well, and there are a good body of literature on that. They are more demanding, of course, but they could both have some good traits and some and bad traits, and I'm going to dive a little into that. So the ones at the bottom, the subfigures, they show different water indexes in the literature. Some of you may be familiar with them, like normalized different water index, for example. So in this case, we're like studying muddy waters that have some vegetation inside them as well. Some of these indices do pretty well, some don't. And if you look at the images on top, the very first two on the far left are actually the actual images from Landsat. And the one in the middle, subfigure C, it's saying global surface water. That's actually a machine learning product that is published, and it's very accurate, and an extensive data set was used to train the model, and it was a rigorous procedure. Which it had a very high accuracy, but as you can see in some particular cases, it fails and it cannot capture like these types of muddy waters. And next to it, ANDWI, a subfigure D, is our proposed index, which perfectly captures the this type of water body. And the way we do it is to use ANDWI and the UTSA thresholding to automate the process of choosing the right threshold to separate water from non-water bodies. Now, next slide. And this is the interface of the app that I'm showing. This is available in GitHub, Google Earth Engine, and it's running in Google Earth Engine, but the code is available in GitHub, and it's also in HydroShare. So do check it out. What you can do, the app allows you to zoom into any area of interest in the world. You can basically zoom in, draw a polygon around the water area that you want, and by running the app, it will give you some information about the water body. For example, the time series of 16-day time series of water body area from 1984 until present. That's one of the outputs. The other output is the shapefile of the water body at different times, which could be used later perhaps in GIS platforms to do extra analysis. And yeah, there are like different range of options in the app which I'm not going into. If you want to check out, I'll leave a link to the app, and we also published a paper based on this. It's in environmental software and modeling journal. I'll leave a link to that. We've got excellent results there. Do check it out. And yeah, I want to encourage all the students and postdocs out there, if you want to dive into something, if you want to build a software or open source code that you want to share with the rest of the community, or even you have it like data that you're producing at the end, check out this award. And yeah, thank you all. And with that, I'll leave it to Jerad.
Yeah, thank you. Arash is finishing up the Summer Institute this week as well, working to get his final paper for the Summer Institute published. So he's got a busy week. So thank you.
Thank
Paula?
you, Jerad.
Yes, hi everyone. I'm Paula Buchanan, and under all of that turnout gear, as they call it in fire departments, that's actually me. I completed the City of Atlanta's Citizens Fire Academy in August during the depth of summer in Atlanta. That gear is very heavy and very hot, but yes, I'm very into working in the field. That's very much a part of what I do. Next slide, please. So a little bit about me. I'm a disaster science and emergency management researcher. And for any of you guys that might work in the emergency management industry or work around emergency managers, one of the things people always ask you, even though it sounds a little weird, is what's your disaster? Like, what is it that you really focus on? So my disaster, in quotes, is actually specifically water, but it's not what you would think in the sense of drought or floods. I actually look at drinking water systems and what's called water stewardship, you know, the interaction between, as Morgan was saying earlier, people and the systems that they use. From my perspective in the work that I do, water availability and access is a hazard that can actually lead to more disasters. So it's a hazard that we have to address. And why water, of all the things that's going on in the world? One thing that I think is really important about focusing on water issues is it's necessary for life. I think you can maybe survive and not even like really live well, but survive without water for only about 3 days, and then you're gonna die. So we all need it. It's a universal issue, and it's also what a lot of people don't understand. It's a limited resource. As one of my professors, Dr. Gregory Shaw once said, water is the new oil, and he's very right on that. So again, I focus on the human impact on the drinking water cycle, systems, and supplies. And as we know, in this group of water nerds, I'm what's called the socio-hydrologist. You know, yay, socio-hydrologist, because while hydrology, of course, is incredibly important and engineers are incredibly important, it's also important to understand the people that use those systems, right? So what I look at is risk communication, specifically in the areas of public education and outreach. You know, how can water professionals more effectively communicate with people that water is a limited resource, it just doesn't come out of your tap, right? I'm also interested in what's called science communication, or hashtag SciComm. Water issues, like I said, it's necessary for life. It's universal. It's a way to get people interested in talking about science. And it's a way that we as researchers can actually learn how to more effectively communicate with the populations that we serve. And I am a Let's Talk About Water Grant Award recipient. Next slide, please. So a little bit of an overview over lessons learned. So before I won this wonderful award, I actually had a pet project during the pandemic. I received another micro grant and I used it to direct and produce my first animated short film called Attack of the Evil Fatbergs. If we have time, we might check it out. If we don't, I'll share the link in chat. So I did that. I got a lot of really good positive feedback about it from the water professionals that I've interned with Veolia Water. And so I applied to CUAHSI to develop a pilot webcomic that also focuses on fatbergs. And beyond what I'm doing now, what I really want to do is to create a lesson plan, as educators would call it, like a portfolio of educational materials that would be free, downloadable, have multimedia components on drinking water availability and access issues that K through 12 teachers and educators can use with their students. Some more lessons learned and more actually, in my opinion, reinforced through this getting this grant is that water is a universal issue. It's relatable to all people because we all need it. And one thing that we as researchers quite often forget about is what I call the so what and then now what. We got this great journal article, we did this great presentation, now what? How is what we do applicable to the people and the populations that we serve? In short, we have knowledge about an issue, but what do we do with it? What can we do? So this is an issue. How can everybody get involved and actively participate in mitigating or lessening the impact of negative issues? Next slide, please. A bit on the professional benefits of getting this award. I'm here, I'm talking to all of you. That's great, right? It's a great way to talk with other people. And as I say it, I found one of my tribes as a socio-hydrologist. So that's great for me. And it's great to talk about the importance of SciComm or science communication in research, specifically water for me. But I think we can all, as very smart academic researchers in various areas, learn how to be more effective in communicating. And again, this also spotlights a universal issue that doesn't get enough attention until there's a drought and there's no water, right? And a little bit more about drinking water availability and access. One of the things that I think has been helpful is I've created more relatable talking points to discuss about the booger bear in the room, climate change, right? So I would think that most people in this room understand that climate change is happening. It is a scientific fact, but not everyone believes in that. And that's something that we deal with a lot as researchers. And dovetailing that into science communication, there's nothing worse than a scientist who waves their finger in your face, like, you have to believe that this is true because I'm right, because I'm the scientist. That doesn't really work with the general public. They don't like being talked to like we're their parents or something like that. So it's really important. And I say this a lot when I do my research. It's really important to meet people, for example, who don't believe in climate change. Meet them where they are, not where we want them to be. That's so important. And water is a great way to open the conversation about that, right? It's not as political as climate change, even though a lot of the people in this room know that water can be a political issue. It's not as political as climate change. And we all need it, regardless of our political affiliations, to live. Next slide, please. So a couple key takeaways, all of us, not just the scientists in the room, but people out there on the street who might not have a traditional academic education, we all have our roles and can all make an impact. Again, I say this because it's so important. Meet people where they are, not where you want them to be. And I don't think we have enough time to watch the film, but again, I will share it in the chat. So next slide, please. And we'll just skip over the video. And thank you for your time. Of course, there's going to be questions and comments coming through now and at the end. If you do have any questions and don't have time, here's my website, my Twitter feed, my LinkedIn profile, and a link to the Fatbergs film. And I will put that in the chat. So thank you everyone for your time, and I really do appreciate it.
Thank you, Paula. And so, right, just a reminder to everyone, type your questions into the Q&A box. So thank you. Okay, next, Jewell, I believe.
Yeah, thank you, Jerad. Hi, everyone. My name is Jewell Lund. I'm a PhD student at the University of Utah, and my researcher's focus is on radar remote sensing of the snow for snow hydrology applications. I am also fortunate to be a student researcher at the Cold Regions Research and Engineering Laboratory. I've benefited from multiple CUAHSI programs that I wanted to talk about briefly today, and the first is the CUAHSI Snow Measurement Field School. For any of you that aren't familiar with it, it's a week-long course for students to learn from experts about theory and practice for various snow measurement instruments and techniques. So in January in 2019, a group of about 50 of us spent a week in Bozeman, Montana, working with a team of really amazing instructors. For those of you snow scientists out there, Jessica Lundquist was there, Kelly Elder, Mackenzie Skiles, Matthew Sturm, Kevin Hammonds. Throughout the week, we had lectures on theory, lots of time in the field trying out different instruments, and a lot of time working on group project ideas, which we then present every evening. It was a really impactful and productive week, and I really appreciate the knowledge and engagement of the instructors that were there, and appreciate CUAHSI for organizing and sponsoring the workshop. I know it was really educational for all of us that attended, and for me, it helped solidify skill sets that I've used extensively in my graduate program, and then also for my Pathfinder fellowship. So next slide, please. I also have benefited from the CUAHSI Pathfinder Fellowship, which I know more panelists will discuss today, but I applied for the Pathfinder Fellowship because of some outstanding questions from my master's thesis. We were using Sentinel-1 radar satellite imagery to look at snow conditions in high alpine watersheds in the Karakoram Mountains of Pakistan, which is very snow and ice melt dependent for their water resources. And Sentinel-1 radar is really sensitive to liquid water in the snowpack. And luckily for us, the satellite orbital pattern allows us to compare liquid water detection in the morning versus the evening. And as we began to look at images from the mornings versus the evenings, it looked like with the satellite imagery, we might be able to detect snow surface melt freeze cycles that take place early in the melt season. This isn't something that we'd seen before with these sorts of instruments. And so we were excited about the potential application of these data for RONAF forecasting or energy balance model validation or parameterization, especially in high alpine basins that aren't very well measured. So the image on the left is an example of this from the Shigar watershed in the Karakoram Mountains in Pakistan. And the cyan color is detected wet snow from the radar imagery. And the dark blue color is presumed dry snow. So the top left image shows wet snow in the evening satellite overpass. And then the top right image shows wet snow the next morning during the overpass. And then the bottom right image highlights the differences between these two in orange. So those orange areas are where we think the surface melt freeze cycles are taking place. To really understand what was going on the ground to compare with the satellite imagery, we obviously some field measurement was necessary, but that wasn't really easy to explore or to organize in the Karakoram Mountains. That being said, though, I did end up going to Pakistan a few years ago for a personal trip. And so this picture is one of my friend jumping over a glacial melt stream on the Chaktoy Glacier. Let's see, next slide, please. So with the hope for field measurement in mind, I applied for the CUAHSI Pathfinder Fellowship, and my hope was to work at one of the field sites for the NASA SnowX campaign, taking measurements that would coincide with Sentinel-1 overflights in the mornings and evenings. And I also plan to take measurements in line with SnowX protocols so that it could allow the data sets to be aggregated and complementary. And for any of you not familiar with SnowX, it's a multi-year, widely collaborative NASA campaign with the goal of developing a global snow satellite concept that addresses our current knowledge gaps in snow remote sensing, again, for really water resources purposes. So for the last couple of winters, researchers have been consistently taking measurements at several designated sites throughout the Western US, coincident with airborne sensors flying overhead. One of the SNOX sites is on Grand Mesa, Colorado, and this slide shows some pictures of our intensive field campaign that took place in winter 2020. So for 3 weeks, researchers gathered and collected an impressive amount of data using various instruments. And the picture on the bottom left there is a few of the researchers wrestling with one of the instruments that got stuck in the cold. So along with participating in the intensive SNOX campaign, I served as one of the primary field researchers throughout the winter on Grand Mesa for SNOX. I live and study in Salt Lake City, so I would drive down every 2 or 3 weeks to take measurements. It's about a 6-hour drive. And the Pathfinder Fellowship supported me to take more measurements on Grand Mesa, and especially focusing on the spring months where we might see surface melt freeze cycles with the snowpack. I coordinated these efforts with SNOX and used their gear for measurements. So I'm grateful for that. Next slide, please. So when I was down for a weekend in early March 2020 for one of my Pathfinder measurement trips, the pandemic ramped up and things really began to lock down, and I was faced with a sort of choice to either, head home and maybe not be able to come back and continue measuring, or I could sort of lock down in place. And I feel really fortunate because I was able to shelter in place safely on Grand Mesa, primarily because of 2 people. Mike and Rose Wenner, the owners of Grand Mesa Lodge. And I knew them because they hosted the SNOX campaign earlier in the season. They're exceptionally generous, and they let me stay in a separate apartment on their property so that I could socially distance and safely continue my research work on the Mesa. So for 6 weeks last spring, I spent most days totally alone, digging snow pits on the Mesa while trying to keep up with my PhD coursework remotely. And the pictures here show some of the views of this work, and I think it's clear that Grand Mesa is a very socially distanced and pretty peaceful place to be during a pandemic. So for the course of those 6 weeks, I dug about 50 snow pits, again, while working on my coursework, and this very much accomplished my field goals with the CUAHSI Pathfinder Fellowship, and I'm so grateful that I was able to continue to work safely instead of sheltering in place in my studio apartment in Salt Lake City. Next slide, please. At AGU last year, I presented a poster with some of our preliminary results, and though COVID and multiple moves have delayed me a bit, the data will be available through the HydroShare portal and will be made available to the SNOX community as well. And there are a lot of practical skill sets and experiences that have benefited from both the snow measurement field school and the Pathfinder Fellowship, but I'd really like to take a moment to recognize the ways that CUAHSI serves as a connector and a venue for community and collaboration. And it's because of community and connection that I was able to safely continue my research on the Mesa instead of returning to Salt Lake City. So community connection and problem solving are meaningful parts of this fellowship that I know I'll bring with me to other personal and professional endeavors, and for that I feel really grateful. So thank you for your time. Thank you for the CUAHSI support, and thanks to the NASA SNOX community.
Great, thank you, Jewell. Joseph.
Thank you, Jerad. My name is Joseph Wasswa, and I'm a PhD candidate in the Department of Civil and Environmental Engineering at Syracuse University. Next slide. So I received the CUAHSI Pathfinder Fellowship in 2018, and my interests were to understand the effects of urban stream syndrome. I was trying to compare, or I'm trying to compare the developing world and the developed world. So my advisor here at Syracuse is Teng Zeng, and I was working with an advisor from Makerere University, Uganda, Professor Noble Banada, who passed away a few days ago from COVID. May he rest in peace. Next slide. So in the USA, here in New York, I was working on the Meadowbrook Creek, which is a creek near here, crosses through Syracuse. And then in Uganda, I was looking at a big drainage channel called Nakivubo Channel, which is the main drainage channel in the capital city of Uganda, Kampala. But in this talk, I'll focus on my trip in Kampala. And my interest, why I decided to work on this work was, I have strong interest in bridging the research gap between the developed world and the developing world. And I want to understand if we can collect information from the developed world, what about the developing world? So my interest was to develop hydrographs in relation to the chemographs and see the connection between the hydrographs and the chemographs. So the chemographs are graphs that I can develop by monitoring the concentrations of contaminants, any chemicals. So in this case, I am looking at the emerging contaminants, which includes contaminants like pesticides, pharmaceuticals, personal care products, and all other emerging contaminants. Next slide, please. So using the CUAHSI Pathfinder Fellowship, I traveled to Uganda and collected samples, over 90 samples. I collected over 90 samples. So for you who don't know where Uganda is, it's found in Africa, East Africa. You see a small red dot there, that is Uganda. And I collected samples from drinking water sources. I collected samples from drainage channels all over the city. I collected samples from self-treatment plants, both water and wastewater, because these are the major sources of these chemicals into these drainage channels. And when it rains, most of these end up into these big channels. Next slide, please. So in this slide, I was taking samples from some of the major drainage channels in and around Kampala. I had an assistant who was taking those photos, but some of those were very risky to get samples from there. Next slide, please. So in this slide, I took pictures. I was taking samples from some of the drinking water sources. These are the major drinking water sources of the population in Kampala, Uganda. Most of people don't have, they are not connected to centralized system, water treatment system. So these are groundwater sources. Some of them are surface water sources. But the reason why I was interested in this is because these drainage channels and poor waste management, these end up into some of these drinking water sources. So I was trying to see, most of these are very near to drainage channels. I was trying to see the effects of these drainage channels to the quality of the drinking water that people take. Next slide, please. So in this slide, I took samples from the lake. I took samples from other drainage channels. And I took these to the laboratory at Makerere University, and I extracted these using solid phase extraction. So I took around 50 mils and then the extracted samples, the cartridges, and I traveled these, I brought this back to the US. Next slide, please. So how did the fellowship help me to advance my career? One is, the truth is it would be practically impossible for me to travel to Uganda to collect all the samples as you've seen, and then travel with those samples back to be able to do the analysis. So I am very grateful to CUAHSI that I was able to perform these analyses on an alternate site in the developing world, which was very important in comparison. Secondly, it helped me to create a very strong relationship with my Ugandan counterparts. So I have a vision. I really am very passionate about bridging the gap, the research gap between the developed world and the developing world. And I have a vision of creating a program where at least we can have students travel to this developing world and have summer training programs and work in hydrology setting and water treatment plants and develop technologies for such communities. And the third one is, so this work is still ongoing. I'm still analyzing the samples, and this work will be out very soon. And I will be sharing all the data on the HydroShare. I have an account there, and I'll also be letting the community know when the paper come out. But I'm very grateful to CUAHSI that I was able to perform this work. I think it helped me to kickstart my collaboration with the people in Africa, and I have a vision of having that going on. Next slide, please. I want to thank you so much. I want to thank CUAHSI. I want to thank the Syracuse Power that finances part of my PhD and everyone who works with me on this project. Thank you.
Great, thanks, Joseph. That's very inspiring. Okay, I think this would, let's see, might be the last one.
Yeah. Hi, I'm Azbina. Hi, everyone. Can you hear me fine?
Yeah.
Okay, thank you, Jerad. Thank you so much for having me. I am not much prepared for the talk because this morning, it was my dissertation defense and I just defended, became doctor. this morning. Thank you. So yeah, it's been a very exhausting for last couple of weeks. So I just prepared like lightly to talk about my experience in CUAHSI Summer Institute 2018. I was a Summer Institute Fellow on that session. And I cannot thank CUAHSI enough for selecting me on that program and providing me with that lifetime opportunity. To be honest, it was a very difficult decision for me to go to Alabama from all the way to Virginia because that time my son was only 10 months old. And I left him with his dad for 7 weeks and joined the Summer Institute because it was my dream. So now I thank myself for taking that decision, that hard decision, and it was a wonderful experience with great learning opportunity of many technical details from experts all over the country. At the same time, I got chances to get introduced with young upcoming researchers in the field of hydrology. The work we had in our team, we were 3 Summer Institute fellows from different part of US, and we were from different research background. John Brackens, who was a PhD student that time in civil engineering at Tennessee Tech. Nishadni Moragoda, she was also she was an MS student that time, now a PhD student in geography at the University of Alabama, and myself. We basically worked on a project to improve the channel geometry interpretation of National Water Model and showed how this improved the river stage and discharge estimation. Basically, the National Water Model channel interpretation is very simple, and it generalizes it with 1:20 side slope and with the interpretation of infinite channel depth. In our proposed channel representation, we suggested replacing the 2 parameters channel representation of National Water Model with 7 parameters by adding 3 extra points with depths and slopes. And we used the hydrodynamic model HECRAS to test out the effects of different channel geometry representations on the stage and discharge. The results showed our proposed channel geometry representation improves the stage estimation with respect to the USGS stage for different channels. And we got wonderful guidance from our team leads, Dr. Christopher Laurie and Dr. Sagi Cohen. Even after coming back from Summer Institute, we stayed in touch and worked all together remotely in our publication. Finally, our article got published in the Journal of American Water Resources Association in the year of 2020. So all the single experiences from the Summer Institute helped me to move steps ahead on my career. I have learned a lot of things as teamwork, presentation, developing different research ideas, working on deadlines, accepting challenges and whatnot. Also, I got amazing network in the field of my own research area. We meet our Summer Institute fellow group in every American Geophysical Union conference. I got new mentors who have been so helpful and supportive since last 3 years. The Summer Institute experience all over was so rewarding, and I suggest all the time, I suggest my mates, my juniors to apply for this wonderful opportunity. I believe those 7 weeks have made me a completely different person in a positive way, and I will definitely cherish the memory of Summer Institute the rest of my life. Thank you, everyone.
Thank you and congratulations. So that concludes our presentations. Thank you to all of the presenters. Yeah, I think as you can see, the little bit of money that we spend has some pretty tremendous impacts on the students. And you know, if you're a student or an advisor, you know, we encourage you advisors to point your students to these programs. They're really impactful. Each of the teams at the Summer Institute, for example, have a paper published in JARA. We just published the edition for 2019, I believe. So this is all impactful work. So we have a question for Paula from Sarah Ledford, and it's I'll just read it to you. I love the video and the continued discussion with the public about the causes of sanitary sewer overflows that we cause. But as someone living in Atlanta, an even larger part of the issue related to these overflows is lack of maintenance. How do you balance speaking with the public about personal responsibility, but also about larger structural failures?
Well, Sarah, I think you said name Sarah. I was about to type it, and then Jerad was so sweet to read it for me. So yeah, that's actually an important issue. And what's funny is my research is based in the city of Atlanta, which has all kinds of infrastructure problems and issues, not just its water system. One of the things I think that's really important is to understand what it is you can control versus what it is you can't control. And maybe control isn't the right word, but people have to figure out what it is that they can do to feel empowered, to have agency. You know, the more people who get involved in an issue, the more likely something might be done about it. And that's the way I look at it. You know, there's no way to solve the crumbling infrastructures in the city of Atlanta overnight. For example, the city still has some pipes that are clay, literally clay. So, you know, they're going to have to be replaced. So there's no amount of community activism or community scientists or awareness that will change that overnight. But, you know, we can actually do our little parts and make a bigger impact.
Thank you, Paula. So seeing no other questions, I think that was the only one. So, you know, for the audience, please check out the chat. There were a number of links that our speakers provided. Thank you again to all of you for great presentations, for keeping on time. And let's see, have we? Yes, so Allison just posted the link for the next webinar beginning at 1, the Eagleson lecture. So we encourage you to hop on over there. So thank you.
Thank you so much.
Thanks, everyone.
Thank you, Jerad. Thank you, CUAHSI. Thank you.
Thank you.